Hello friends, welcome back to JEE Blunders, where you learn the don'ts first. Today let's continue our series on trigonometric equations and evaluate sine inverse of sine 2. So in general, we know that f inverse of f of x must equal x, just by definition of the inverse, right? So sine inverse of sine 2 is 2. That does seem a little too good to be true. So I encourage you to pause the video here and think about whether this is true. So assuming you have paused and thought about it, let's just try to look at the graph of sine inverse of x, and I think that will help us understand what is going on here. Right, so we know that the domain of sine inverse x. So here I'm graphing, just to be clear, I'm graphing sine inverse of x. And if we look at the domain of sine inverse of x, it has to be from between -1 and 1. And the range, the way we define it, has to be between pi by 2 and minus pi by 2. So sine inverse of 1 would be pi by 2. Oops, don't know why that happened. Okay. So sine inverse of 1 would be pi by 2. Sine inverse of 0 would be 0. Sine inverse of -1 would be minus pi by 2. So we would have something that looks like this. Or let me use a different color for this. Right? So sine inverse of sine 2, by the way, the first or the most important thing to realize here is that 2 is an angle, right? We're used to thinking about angles in pi's or multiples of pi, but it could be anything, doesn't have to be a multiple of pi. So 2 is an angle here, and 2 is in radians. So by degrees, by default in math, when we refer to an angle, we refer to it in radians, right? So 2 is in radians, and right, we need to understand how much is that in terms of something we are already more familiar with. So how much is 2 radians actually? So 2, pi by 2 is around 1.5. Pi is 3.14, so pi by 2 is 1.57, right? And pi was 3.14. So 2 radians is between pi by 2 radians and pi radians. So that's where 2 lies. And so the sine 2, I guess here we also have to plot sine x to understand where sine 2 would be. It would be helpful to plot sine x as well. So there's pi by 2, and there's pi, right? And this is y equals sine x, and this is y equals x. So sine 0 is 0, sine 0 would be 0, sine pi by 2 would be 1, and sine pi would be 0 again. So sine 2 lies somewhere here, and so sine 2 would be somewhere between 0 and 1, as we would expect, right? So sine 2 lies somewhere between 0 and 1, and when we input that to the function sine inverse x, we would expect to get some number between 0 and pi by 2, right? So there's no way it can actually be 2, because 2 lies somewhere here. If you were to look at the y-axis, 2 is greater than pi by 2, right? 2 lies somewhere here. So there's no way this can actually be true. So this is actually sine inverse of sine 2 cannot be 2, because sine inverse of something can only lie between minus pi by 2 and pi by 2, and 2 is outside of that range, right? So that is the key learning here. So the key lesson to be learned is sine inverse of sine x equals x only when x belongs to this range. Only for these values of x can we use the standard form of f inverse of f of x. So that is the key lesson learned. So before we wrap up, let's try to solve the original problem. How do we solve sine inverse of sine 2? Because 2 does not lie in this range. 2 is greater than pi by 2, right? So we can use some fairly straightforward trigonometric identities to actually convert it to that form. So sine inverse of sine 2 can be rewritten as sine inverse of sine. So sine x is also equal to sine of pi minus x, right? So sine 2 is also sine of pi minus 2. Right, and now pi minus 2, so pi is 3.14, pi minus 2 would be 1.14, and so that lies in this range, right? Because pi by 2 is 1.57, minus pi by 2 is 1.57, and oops, let me quickly clean that up. And so pi minus 2 is approximately 3.14 minus 2, so that's approximately 1.14, and that does lie in this range. And so now we can apply this identity now, because we have converted it into this form. And so sine inverse of sine x will be equal to x, because in this case the x belongs to this particular set of values. And that's it, we are done. And so the key lesson to be learned is that sine inverse of sine x equals x only for these values of x, only when x belongs to minus pi by 2 to pi by 2, and otherwise it can be converted to a form using these trigonometric identities, and then you can apply this function. So hopefully this was an important and useful lesson for you, and I will see you in the next video. Bye.